Right. Well, today we're going to start off with a CAD lesson really quick on drawing, and then we'll get into the programming stuff later. I didn't have enough of a CAD lesson to justify a whole meeting. Like, this should take like 15 to 20 minutes at the most, and then we'll go into programming. What I want to show is a feature of any CAD software that we use a ton. I'm going to go into the rollers example that we made quite a while ago at this point, but it's useful for this example. Um, so you have this CAD here, and it's great. And if you're just gonna, send it to a 3D printer, you like, or any kind of computer controlled CNC way to make this, you just like export it to STL, millimeter, all that's fine, and you hand it off to the machine. But what if a human has to make it? What do you think is a good way to uh, get the dimensions on this in such a way that a human can read them while making the part? I'll, I'll put chat up, and you guys can answer how you would have a human make that part from CAD, like, and relay the dimensions to them. If you've had IED, you're probably very familiar with it. Or at least I sure was when I took IED. Text on it with the dimensions. Uh, so yeah, Will says put text on it with the dimensions. I mean, pretty much, yeah. Not exactly, but what we do is we make what's called a drawing file, and then we dimension that. So, screen capture. Um, Go here, and you right click on your part, and you do create drawing of, and then it just says the part name. So this has recent open because I played around with this a bit to make sure I knew how it worked. But what you want to do is you want to go to Onshape, ANSI A_A_inch is the template you want to use to print out of a normal printer that we all have. ANSI A is just 8.5 by 11. And they have this button here to go to 4 views, but that like auto scales it for you. You have a lot more control over like the scaling and stuff if you just go with no views and then hit OK. That will pull your part in, and you can go in here and you can change the view scale. Um, if you can do one by one, like make it as big as you can actually fit on the paper. And so it defaults to a front view. So you click down in the bottom left here, and it auto starts projecting for a top view. So I click down here, and without clicking in, I can move up here, and here's your top view. I click there, and it says it's done. What I can then do is click back on the front view, move out to the right, and it will project out a right view, which in this case is the same, but a lot of parts it isn't. Uh, Windows being very slow today. And then here it wants to project out this view. That's actually not what I want. What you want to do is you want to click down here. What you do is you want to click down here. Okay, this was working earlier. Hold on. Oh, insert view. Okay, so if it doesn't auto project the isometric, you can just manually add the isometric by hitting that insert view button. Yeah, there's that. And then there's the dimension button here, or you can just hit the D key. So, that gives your OD of 2.77. I accidentally got that line. Click there and then there. That gives you your flat to flat hex size. Click there. Get the thickness. And for this part, that's about all you need. And to even properly inserted the scale down here, and if you zoom in here, or if I zoom in here, you can even see it like insert your name in as like who drew the part. You have checked and approved. You can put in like a material and a finish if you want extra stuff. If you have a CAD weight, you can put it in that box so the fabricator knows how heavy it's supposed to end up being based on the CAD. You can give it a drawing number and a revision number if you want, a title. Like you have boxes in here just to put information with it. Oh yeah, other dimensions that you would absolutely want is the radius of that curvature, the radius of that chamfer on the edge. And then I think that's about all you can mention. Yeah, drawings. I'll go ahead and just, because people's windows were slow, etc. I'll just right click, get another drawing of flat roller. It'll be in the on shape. Well, unless you've done this once, in which case it'll show up in the ANSI underscore A underscore inch. Do that. Get another drawing. It defaults to the front view. That usually goes in your bottom left. There. And normally what you can do is you can just click there and click over to get your right view. Then click over and click up here to get your isometric. I don't know why it didn't work on the other one. I had to manually put in the isometric, but and then dimensioning this one's a lot easier because it really is just OD to flat and thickness. Then what you can do is you can right click down here and do export and export it to a PDF like so. And then Onshape, if you're like importing or exporting a lot of times, it'll go up here with the notification. It'll actually pop up here. You'll have a PDF file for your drawing that you can then, well, no, I don't want to download that again. You can then hit the print button up here and print it off. This is really handy for any kind of sheet part. Like, for a lot of times we like laser cut Lexan, but sometimes it's either something that won't fit in the laser or, we're cutting a simple piece of aluminum or something. What you can do is you can put a drawing in here in 1x1, 1-to-1 scale. Literally tape that, cut the drawing out, tape it over the part, and just manually cut it out really quick because it's in 1-to-1 scale. Drawings are really important. The other thing I want to show is this is a good part to show it on. I'm actually going to flip over to B1 for this because I don't want these changes to be saved really. Is fillets and chamfers. We use fillets and chamfers all the time. So a fillet, and you click the fillet button, it gives you this entities to or fillet, and you can pick a radius, Larger radius means, well, you end up with stuff like that. Tighter radius means it just barely takes that corner off. That's a fillet. It's a rounded corner with a radius. Then a chamfer is a kind of beveled corner, kind of squared off. We actually could have made our rounded rollers by picking the OD and then doing a fillet or a chamfer and picking the radius. It's just not how I wanted to do that. And the distance kind of works a lot like the radius, except it's straight across, 0.5, just like that. And if we wanted to, I could do like a chamfer on two surfaces, and bam, this flat roller is now a crowned roller. Not at the right dimensions for our robot, but that is technically a crowned roller. So I would actually recommend something more like that, if that's really what you're trying to accomplish. But anyway, that's all I've got for CAD today. We're going to get into some programming stuff now, but I'm going to restart the stream to make editing the VOD later easier. And in fact, I wasn't even recording